In order to verify that a function is one-to-one, we have to make sure that it passes the horizontal line test. Now, if you want to graph this on your calculator to see what the graph looks like, that would be fine. I know what a graph of x to the third is going to look like roughly. This graph is going to look roughly like so. And if you don't believe me, then graph it on your calculator and you can see that I'm right. This graph then does pass the horizontal line test. No matter where I draw a horizontal line, it only intersects one time. So yes, this graph is in fact one-to-one. That's good because what that means is the inverse of this graph will also be a function. So the second part of this question said find the inverse. So to do this, as we've always done when we find inverses, is I'm just going to switch around x and y. Remember, f of x is just a fancy looking y. So if I rewrite this problem with x and y flip-flopped, I get x equals 2y to the third and then plus 4. And even though this technically is the inverse function, we always like our functions to say y equals, so I'm going to go ahead and rearrange this one and solve for y. So I'll do this the same way we've always done things. Go ahead and subtract 4 from both sides, so x minus 4 would equal 2y to the third power. Next up, let's divide by 2. And I'm just going to do the whole side divided by 2, so I end up with x minus 4 over 2 equals y to the third power. To get rid of a third power, I'm going to take a cube root to do that. So I'll take a giant cube root of this other side, and then a cube root over here. Those will cancel out, and if I go ahead and rewrite this problem, make it look a little bit neater, I'll end up with a final inverse function of y, or if you want to be really fancy, our inverse function notation is this, the f of x with a little -1 in there. So you could use either one. But anyways, y equals the cube root of x minus 4 over 2. A cool way to kind of check, not officially check, but kind of check these, is to graph both functions on your graphing calculator. Graph your inverse function and graph your original function, and if you've found the correct inverse, what will always happen is your graphs are always going to be symmetrical about the line y equals x. So some of these look really cool. If you're into art and pretty things like that, you can try graphing some of these. And it doesn't necessarily prove it, but if you see that you're completely not symmetrical, it's probably a good indication that you've done something incorrect as you found the inverse.